Alright, so in this problem I'm going to add 2/5 plus 1/6 to find that sum. And so what I notice here when I first do this is I'm trying to add fractions, but the denominators are not the same. Denominators tell me the size of the pieces, and if my pieces aren't the same size, I can't put them together. So what I need to do is find what's called a common denominator. I need to find it so they have the same denominator in both fractions, and that will allow me to find a sum. So in order to find a common denominator, I'm actually going to list out the multiples of each of my denominators. So I'm going to put the multiples of 5, and I'll list a couple of them, 5, 10. I can get these on my multiplication table if I'm not sure. 15, 20, 25, 30. And I can just keep listing them until I get bored. I can always go back and add more later if I need them. And for this one, the denominator of this fraction is 6, so I'll also need to list the multiples of 6. And again, if I need to pull them on my multiplication table, I can. 6, 12, 18, 4, 30, 36. And then I need to find the least common multiple. So I'm looking for the one on this list that they both have, and here I see that 30 is a common multiple, which means I can use that as my denominator for both fractions. So what I'm going to do is I'm going to go ahead and I'm going to rewrite both of these fractions using 30 as the denominator. So I had 2/5. 2/5 has to equal something with a denominator of 30. And then I also had 1/6. And 1/6 is going to have to equal something that can also have a denominator of 30. And the way I switch to an equivalent fraction with the right denominator is I figure out what I multiplied 5 by to get to 30. So in this case, 5 was 1, 2, 3, 4, 5, 6 times. 5 times 6 gives me 30. If I did that to the denominator, in order to make it equivalent, I also need to do it to the numerator. So 2 times 6 is going to equal 12. On this fraction, I need to know what I multiplied 6 by to get to 30. It's okay that this is going to be different as long as your numerator and denominator are multiplied by the same thing. You don't need to have the same number in both fractions. So here we'll have 6 times 1, 2, 3, 4, 5. 6 times 5 makes 30. Because it's the same fraction, I need to do the same thing to my denominator and my numerator. 1 times 5. So up here, 1 times 5 will give me 5. Now I've got this same problem up here, 2/5 plus 1/6. But what I can do is I can rewrite that using these fractions. They're equivalent, but now they have the same denominator. So 2/5 is going to turn into 12/30. So I'll write that one first. And then 1/6 turned into 5/30. So instead of 1/6, I'm going to write 5/30. And then just like before, I was adding here, I'm going to keep adding here. And the trick is just, my denominators tell me the size of the pieces. So my denominators I don't need to add because it's 30th is the size. I want to keep that. I did all of this work to get 30 as the denominator. I don't change my denominator. What I can add is my numerators. I have 12/30 and 5/30 all together. 12 plus 5 gives me 17. I have 17/30. When we go on and start looking at that, when I have mixed numbers, I'm going to go through the exact same process. The only catch is that first I'm going to want them all to be fractions. So what I'm going to do is I'm going to convert from 4 2/3. I want that to be an improper fraction so that I can go through this same process. In order to convert 4 2/3, what I'm going to do is I'm going to remember that there's a quick shortcut for me to turn this into an improper fraction. I'm going to make my loops, and then I'm going to multiply on the bottom and add up here. And what I'll do is 3 times 4 gives me 12, plus 2 more is 14. And like always, it's my favorite part of the fraction, I keep my denominators. So I get 14/3 is the same as 4 2/3. So what I'm actually going to do is I'm going to go ahead and I'm going to rewrite this problem. But instead of 4 2/3, I'm going to make it 14/3 so you can see. It is the same thing, but I'll put 14/3 in for here, and I'll keep plus 5/7 because that was already, there's no whole number in that, that's safe. So now I'm going to add these exactly the same way as I added the fractions on the last one, because now there's no whole number that I need to worry about. It looks exactly the same as it did before. So I'm going to go through my steps. I'm going to first list my multiples of my denominators, my multiples of 3, and my multiples of 7. And that'll allow me to find the common denominator. So I'll list the first couple for 3, because that's my first denominator. 3, 6, 9, 12, 15, 18, 21. And for 7, 14, 21. And I very quickly can see that my common denominator is right here at 21. So again, what I'm going to have to do is I'm going to have to rewrite my fractions using this common denominator. So I'm going to take my first one, was 14/3, and I'm going to have it equivalent to the same fraction with 21 now as my denominator. And I'm also going to take 5/7, and I'm going to rewrite that as a fraction with 21 as the denominator. I need to think about what I multiplied 3 by to get 21. 1, 2, 3, 4, 5, 6, 7. 3 times 7 is 21. Do the same thing to my denominator and my numerator. 14 times 7. I actually don't know 14 times 7 off the top of my head, but it's okay. I can just come over and find some space, and I can multiply 14 times 7. Totally fine to just go find another corner. 4 times 7 is 28. If you use lattice here, that would be fine also. 1 times 7 is 7, plus 2 gives me 9. 14 times 7 is 98, and I can just come back and put it here. I can forget about this as scratch work. And then down here it should be a little easier because 7 times 1, 2, 3 gave me 21. Same thing to my denominator and my numerator. 5 times 3 I know in my head is 15. And now I have 2 equivalent fractions all the way back from up here. 4 2/3 turned into 14/3. I'm adding that with 5/7, and now I just made 2 new fractions that are equivalent to these. They just have the same numerator. So that it helps you to see it, I'm going to go ahead and I'm going to erase these. So I had 14/3. I remember that turned into 98/21. I'm actually going to erase this and rewrite it as 98/21. And I added 5/7. I remember 5/7 is the same as 15/21. I'm going to rewrite it as 15/21. And now I've got a problem that has the same denominator in both. When I go to find my sum, I keep that denominator. It tells me the size of the pieces. And I need to add 98 and 15. Probably can't do that in my head. Again, it's totally fine if I want to come over here and do 98 plus 15 as my scratch work. I know 8 plus 5 is 13, and that gives me 11. I have 113/21. I'm going to go on now and look at a word problem here. This word problem tells me that Jen is using a wooden strip that is 4/5 yards long to make a picture frame. She cuts off a piece of that that is 1/8. I'm going to assume that's 1/8 yards. Which fraction best represents the portion that is left of the original strip? So just so I can get a visual of this real quick, because it's a word problem, I would consider that Jen's using this, so she's got a wooden strip of something, and it's 4/5 of a yard. So she's holding something, it's about that big probably. She's making a picture frame. I don't really care what she's making with it. She's going to cut off a piece. So she's going to take this, and she's going to take her knife or whatever, and she's actually going to remove a piece of it that's 1/8 of a yard. And I want to know what fraction best represents the portion that is left. So in my mind, I started with this whole thing, and I took away a piece. That's a big cue to me. It's going to be a subtraction problem. So I'm going to set up that she had 4/5 of a yard. I'm going to forget my units for a little while. Don't tell your science teachers. Forget them just for a minute. It's 4/5 of a yard, and I'm going to take away, because she cuts off 1/8, and we want to know what's left, which is a good cue word that it's a difference problem. So 4/5 minus 1/8. Once again, I can't work with adding and subtraction if the pieces are not the same size. So 5ths and 8ths, I can't take away from each other. I need to go through the same process. So I'm going to go ahead and list out my multiples of my denominators. And for 5, for my 5ths here, it's 5, 10, 15, 20, 25, 30, 35, 40, and I know how far to go because I know these multiples really well, but again, if you pick the wrong number, it's okay, you can always keep going later. Multiples of 8 are 8, 16, 24, 32, oh look, 40 again. that's going to be my common denominator. I'm going to be able to go ahead and switch both of these into fractions that have 40 as the denominator. So to set that up, I'm going to start 4/5 is the same as a fraction with 40 as the denominator. And 1/8 is also going to be the same as a fraction with 40 as the denominator. I know 5 times 1, 2, 3, 4, 5, 6, 7, 8 makes 40. You can do the same thing to my denominator and my numerator. 4 times 8 is 32. And then I need to do something over here. 8 times what is 40? 1, 2, 3, 4, 5 8s make 40. And again, if I do it to the denominator, I have to do it to the numerator. So I have to do times 5 up here, and I get 5. Once again, I'm going to erase these so you can really see what I'm doing. 4/5, I'm going to convert to 32/40ths. I'm going to come up here 4/5, and in its place, I'm going to write 32/40ths. 1/8 is the same as 5/40ths. Oops, it's not what I meant to replace. This can stay 5/40ths. 1/8 though, up here, I'm going to change to 5/40ths. This is where I care about the same denominator. 5/40ths. And then I can subtract. Once again, I did all that work to get that denominator. It just tells me the size of the pieces. I'm going to keep that. And I'm going to subtract 32 minus 5. That's 27. And I've got here my difference. If I had 4/5 of a yard long piece of wood and I took away 1/8 of a yard, I would be left with 27/40ths of a yard. Mr. Brown read 1/8 of his book to the class on Monday, 1/10 of the book on Tuesday, and 2/5 of the book on Wednesday. How much of the book has he read to the class so far this week? So I'm going to sort of envision my favorite way to draw everything. This is Mr. Brown's book. It doesn't look like a book. That's totally fine. Thinking about the fact that so on the first day he sits down and he reads 1/8 of it. I'm not even going to worry about drawing it out for you. I'm just going to try and visualize this problem. So 1/8 of the book is how much he gets through on that first day. So this is like Monday. Then he comes in, that was Monday. 1/10 is Tuesday. So there's another fraction he reads on Tuesday. And then 2/5 of his book on Wednesday. So then there's another fraction, 2/5 on Wednesday. Notice it really didn't matter what size I'm cutting. I'm just trying to understand what's going on. How much of the book has he read to the class so far this week? So I'm looking at Monday, Tuesday, Wednesday. I want to know how much he's got through. I need to put all 3 of those days together. It's a good cue that I'm going to add. So in this case, this problem is going to be 1/8 of the book. And then the next day he reads more. So he reads 1/10 of the book. And the next day he reads more. So he reads 2/5 of the book. And I want to know how much that is all together. This is going to be tiring, but it is again the same exact process. What I need to do first is make sure they all have common denominators.